Namaste students, welcome to my channel Sumanth tutorial. In this session, I am going to explain you the concept of work done, mechanical energy and power. Before starting to this session, if you have not subscribed my channel, please subscribe it and don't forget to like, comment and share. Thank you. Students, so let us begin with the basic concept is work. So what is work done? The very basic and the easy definition of the work done is the force applied on the object to change its position. So one thing that you should note it down, when we are going to say that work is said to be done, when the force is applied on the object to change its position. So two things you should note it down. One is force applied. Second one is the displacement of the object. If the things is satisfied, then only we can say that work is said to be done. For example, here there is a chalk piece. I am applying the force to break it. Work is done. But there is one more condition. Now you can see this wall. I am trying to push it. I am applying a lot of force here, but there is no movement of the wall. So what we are going to say this condition? This condition we are going to say work is not said to be done even the force is applied. That is also, you should check that one. There are two things that you need to concentrate. One is the magnitude of the force. Second one is the displacement of the object. So it is very clear that the condition for work is said to be done, the force must applied on the object and there should be some displacement of the object. It means the position of the object must change, sometimes shape or size. The force is applied, but still there is no change in a physical state of the object. The work is not said to be done. Now the factors. So what are the factors on which the work is said to be done? That is depends, as I said earlier, the two factors. One is the magnitude of force. Means how much of force you are applying on it. More force, more work done. For example, if you want to lift a bucket of water from the well, we are going to use a lot of force. We are going to apply a lot of force so that the bucket of water will lift up. So it's going to come up. So meaning the force is applied. If you want to open the door, we are going to put a lot of force on it. First thing is the magnitude of the force. More force, more work done. And the second one is the displacement. Here also in a displacement, more the distance of the object move, more the work done. That's all. So if you want to pull a car, the car is going, you want to pull that car, we are going to apply the lot of force, and how much of distance the car is changed, that will be its work done. So I repeat very clearly, there are two factors affecting the work done. One is the magnitude of the force and the next one is the displacement. How we can represent the work done is equal to the product of force applied into the displacement. So the work done is equal to F into S. So I am going to say the work done is equal to the product of the magnitude of the force applied into the displacement of the object through the direction of the force applied. Next will be its unit. So the unit of work done is very clear, Newton meter. So the SI unit of force is Newton, SI unit of displacement is meter. So the unit of work done is Newton meter or joule. So how we can define the work done? If the force of 1 Newton is applied to move a distance of 1 meter, then that is considered to be 1 joule of work done. So I repeat, how we are going to define the unit of work done. If the force of 1 Newton is applied to move a distance of an object through 1 meter, that is considered to be 1 joule of work done. See here, I said the SI unit of work done is Newton meter or joule. So there are few bigger units than joule. So which is that? Kilojoule. So it will be equal to 1000 times of the joule. And one more is there, megajoule. That will be equal to 10 power 6 10 of the joule. Not only that one, we are having one more unit, that is kgf, kilogram force, and the value of 1 kgf will be equal to 9.8 joule. So I want you to please make a note on this one. Kilojoule, 1000 times of the joule, megajoule, 10 to the power of 6 joule, and 1 kgf will be equal to 9.8 joules. Now let us solve few numerical based on the work done. So the given force F is equal to 30 Newton, moves a distance of 5 meter. So what is the work done? Next step, substitute to the formula. We know work done is equal to force into displacement. In some of the text they had given displacement in D, so you can use either S or D. Next is the value 30 into 5, so it is 150 Newton meter, or you can write it as 150 joule. Now let us solve the second one. In that they had given m is equal to 20 kg, the distance moved is equal to 2.5 meter, the force acting on gravity is 10 Newton. We need to find the work done. Okay, we can easily find out. But question arises, sir, where is the force? Force is not given. First we need to find the force. Very good. So that is F is equal to m into g. First we need to use this formula. Substitute the value. M is 20 into g is 10. It is 200 Newton. The force is 200 Newton. Clear? Now we can easily find out the work done. Formula of work done is equal to force into displacement, that is 200 into 2.5. 2.5 is the displacement or the distance moved by the object. So the force applied is 200 Newton. So when you multiply, you will get the answer as 500 joule. Yeah, students. Now let us solve question number 3. So it is very clear that there is a force of 10 kgf is acted on an object to move a distance of 0.5 meter. What is the work done? Take 1 kgf is equal to 10 Newton. Now solve it. See here, 1 kgf is equal to 10 Newton. Then 10 kgf is equal to 10 into 10 is equal to 100 Newton. That is the force. What is the force? Force applied is 100 Newton. We need to find the work done. Substitute the value. Work done is equal to force into displacement. That is 100 into displacement is 0.5. 100 into 0.5 is equal to 50 joule. Yeah, students, now I am going to explain you the content of mechanical energy. It defines that the energy possessed by an object due to the state of rest or motion is called as mechanical energy. Here two things that you should note it down. One is the object at rest and the object at motion. The energy possessed by the body either by its state of rest or by motion is called as mechanical energy. Based on these 2 points, there are 2 types of mechanical energy. First one is potential energy. And the second one is kinetic energy. So, what does this potential energy defines? The energy possessed by an object by virtue of its position. I repeat, the energy possessed by an object by virtue of its position is called as potential energy. Next is kinetic energy. The energy possessed by an object by virtue of its motion. Very important, that is the second one. I repeat, the energy possessed by an object by virtue of its motion is called as the kinetic energy. Let me write the first one. Potential energy represented by P dot E or capital letter U. So it is very clear that I said the energy possessed by an object by virtue of its position, means in very clear word I will say the stored one. The energy possessed by an object, when the energy is stored in that object, that possesses potential energy. The very important equation, potential energy U is equal to mgh, where m represents mass, g represents acceleration due to gravity, and h represents the height. So that relates to the gravitational potential energy. If the object is moving with respect to the gravitational force and the potential energy acquired by it, that comes under the gravitational potential energy. Then by looking at this equation, 2 things is very clear on which factor this potential energy depends. It depends on the 2 factors. First one is the mass. More mass, more potential energy. The best example I am going to say that you are having the 2 things before you. One is the bicycle and another one is the car. Which possesses more potential energy? Obviously car. Why? More mass, more potential energy. When you compare a bicycle with a car, the potential energy, or in direct way I mean to say with respect to the mass of the car is more compared to that of a bicycle. So it is very clear that if the mass of the object is increased, then obviously the potential energy also increases. Very good. Now the second one is height. Don't say that, sir, by the example it should be g, right? But I won't take g. Why? It is constant. It's constant, it is not varying. So which factor it is varying is the height. So it is very clear that with the expression, if the height increases, potential energy also increases. With the basic example I will say overhead tank. we are going to store a lot of water in a overhead tank. We are going to keep the overhead tank in the ground floor or in a cellar? No, right. We are going to keep that one above the building. If it is a two-story building, above that one we are going to keep. Why? As the height increases, the potential energy also increases. Means this potential energy is directly proportional to the mass as well as the height. If both increases, potential energy increases. Now comes with the unit. Unit is joule, fixed. Yes, a unit of energy is joule, then obviously potential energy is also joule. Now let us solve few numericals based on this content, that is potential energy. Yeah, the question follows like this. We are going to find the value of gravitational potential energy, that is U is equal to question mark. When the object is placed at the height 15 meter, if the mass of the object is 2.5 kg and take the G value as 10 Newton. So first ever step, use the formula U is equal to mgh. Second step, substitute 2.5 into 10 into 50. 2.5 into 10 is 25 into 15. Yeah, it is 375 joule. Now the second one. Here they had given two objects of same mass. Mass is same between the two objects, but they had kept two different heights, h and 2h. They said compare gravitational potential energy. Remember students, whenever you are going to get this kind of a question, very simple, first substitute to the formula, compare means take its ratio, and finally represent the answer in terms of ratio. That's all. So I repeat, if this type of question is asked, first substitute the value, then final answer keep it in a ratio form. So we know the formula U is equal to mgh. Another one, we are going to take U dash is equal to mg2h. Why? M remains same, they only given. G will be same. What it is changing? Only the value of h. Compare. So U divided by U dash is equal to mgh divided by mg2h. M and G get cancelled. H 1 times. So it is 1 by 2 or 1 is to 2. Students, in this numerical they had given very clearly the gravitational potential energy is 1.5 into 10 to the power of 4 joule, having the weight about 150 kgf. Take the value of G as 10 Newton. We need to find the value of H. Don't panic, it is very easy. First thing is use the formula U is equal to mgh. Substitute the value 1.5 into 10 to the power of 4 is equal to M is M into G together only they were given now. So that is 150 into 10 into H. That's all. 150 into 10 is equal to 1.5 into 10 to the power of 4. Which value we need to find out? H. Very easy. See here. It is 1.5 into 1, 2, 3, 4. Easiest way. Is equal to 1500 into H. So next step. H is equal to 15, 1, 2, 3 divided by 15, 1, 2. Easy, right? See here. 10 to the power of 4 means 10,000. 1 point into 10,000 is 15,000. then 1500. So cancel these two zeros. So 15 tens are h is equal to 10 meter. Yeah, students. Now in the fourth question, they had given like this: if the potential energy is increases to 100 joule, having a mass about 0.5 kg, take the value of G as 10 Newton. We need to find the value of H. Direct substitution, no need to panic here also. That is U is equal to mgh. So U is 100 is equal to 0.5 into 10 into H. Next step, H is equal to 100 divided by 5. How? 0.5 into 10 is 5. So it is equal to 20 meter. 5 2s are 10, 0. H is equal to 20 meter. Yeah, students. Now we are going to discuss the concept about the kinetic energy. As I said very clearly, the energy possessed by the object by the virtue of its motion is called as the kinetic energy, that is represented with K dot E or K. See here, K is equal to half mv square. That is a formula to find the value of the kinetic energy. Here m is the mass, v is the velocity in which the object is moving. So why we need to consider? Because as I already said, kinetic energy directly depends on the object which is in motion. So here also the two factors on which this kinetic energy is depending. First is the mass. As the mass increases, the kinetic energy of the object increases. So it is very clear that you can also do this one. Take a stone, another one is the cloth. Throw both one at a time and notice which will going to move fast. Obviously the stone, right? Rather than the cloth, the stone will move forward. Why? Because the mass of the stone is more compared to that of a cloth. So it is very clear that if the mass increases, the kinetic energy also increases. The second one is the velocity, obviously directly proportional to the square of it. So if the velocity increases, then kinetic energy also increases. So second one is the velocity. If the velocity increases, then the kinetic energy also increases. So these two are the factors on which this kinetic energy is depending. Now let us solve few numericals based on this content. The object of mass 60 kg moving with the speed of 50 meter per second, find out the kinetic energy. First ever step, substitute to the formula. We know kinetic energy is half mv square. Second step, half into m is 60 into v is 50 square. So half into 60 into 50 into 50. 230 is a 60. So 30 into 50 into 50. First number, 5 5s are 25. 25 3s are 75. It is 75,000 joule, or in a standard form 7.5 into 10 power 1, 2, 3, 4. Yeah, students, in a second question it is like this. The mass of a truck is 1000 kg, which is changing its speed from 36 km per hour to 72 km per hour. What is the change in kinetic energy? I repeat, the mass of a truck is 1000 kg. Moving with the speed, its speed changes from 36 km per hour to 72 km per hour. What is the change in kinetic energy? Very easy. Don't panic, we need to do 2 steps, that's all. I will going to teach you in very simplest way. First thing is, they had given a value in kilometer per hour. You need to represent in meter per second. In my first ever video, I taught this method. Now I will directly substitute, that is 36 into 5 by 18. 18 twos are, it is 10 meter per second. That is the value of V1. Likewise, 72 into 5 by 18. So 18 fives are, 18 fours are 72. So it is 20 meter per second, that is V2. So I repeat, V1 will be 10 meter per second, V2 is 20 meter per second. You might have asked the question, sir, why you have changed this one? It is very clear that mass is given in SI and kilometer per hour is not the SI unit of the speed. The SI unit of speed is meter per second only. So it's a mandatory, we need to convert the given value in terms of SI. Next is the formula. We know the formula, kinetic energy is half mv square. Now I will continue here. There is a change in a speed, then kinetic energy is half m v2 square minus v1 square. That's all. Then substitute the value, half into 1000 of V1, V2 first, 20 square minus 10 square. So half of 1000 is 500. 500 of 400 minus 100, that is 500 into 300. 5 threes are 15. 1, 2, 3, 4 joule, or 1.5. 1, 2, 3, 4, 5 into 10 power 5 joule. Yes students, finally I am going to explain you the concept of power. So what it defines, it is very clear that the power is the rate of change of work done with respect to time. That is power P is equal to work done divided by time. So how much of work is done in a given time, that ratio is called as the power. So the unit of power is watt or joule per second. Why? The SI unit of work done is joule divided by the time is second. So we can represent the unit of power as watt or joule. So how to define? If I say the power is 1 watt, if the power is 1 watt, then the work done, 1 joule of work done, 1 joule of work is done in 1 second. I repeat, if 1 joule of work is done in 1 second, that is 1 watt. You might have heard this question, define the unit of power. It is very simple, the unit of power is watt. If I say the power is 1 watt, 1 joule of work should be done in 1 second. So what are the factors on which this power depends? Here also there are 2 factors. First is the magnitude of the work. The magnitude of work done means how much the maximum work is done, more is the power. And second one is time. Don't say that more time, more power. It is wrong. it is less time, it is more powerful. Why? It is very clear that P is inversely proportional to the time. If the machine is consuming less time to do the work, that is most powerful. So it is very clear that work done is maximum, more powerful. Less the time it is consuming, it is more powerful. So these are the two factors on which the power is depending. Yes students, so let us solve few numerical based on power. So the first numerical follows like this. A machine which is going to do the work done about 4 into 10 power 5 joules in time t is equal to 10 seconds. What is the power? First step, formula. P is equal to work done by time. Next is substitution. 4 into 10 power 5 divided by 10. So what density is 4? So the power P is equal to 4 into 10 power 4 watt. Yeah students, in a second question it is like this. There are two girls A and B. They are climbing the steps. First girl takes and the second girl take the same thing to climb in 15 seconds. We are going to compare its work done as well as its power. One thing that you should note it down, work done is independent of the time. So work done is equal to force into displacement. Here they are climbing the same steps. It is independent of time. Therefore, its ratio is 1:1. So the work done ratio is 1:1. Now we need to find its power. We know the power formula. Power is equal to work done by time. So P1 by P2 is equal to work done divided by 20 whole divided by work done by 15. Work done is same. As I said earlier, work done remains same. So work done remains same. So what I left with? 1 by 20 whole divided by 1 by 15 or 1 by 20 into 15 by 1. 5 3s are 15, 5 4s are 20. Therefore, the ratio of the power is equal to 3:4. Thank you students for your support, and please send a comment regarding the which topic that you want me to explain. And finally, if you have not subscribed my channel, don't forget to subscribe and like, comment and share. Thank you.